My name is Kelly Morrison. I'm giving a talk today about AI. Basically, the purpose of this talk is to talk about how it might affect our jobs in the future. If you're afraid that AI is going to take your job away, I'm going to take a look at that. We're going to assess it, and then I'm going to give you some tips about things you can do to protect your career. So hopefully you'll still be employed 20, 30, 40 years down the road. And because we have a lot of different talks going on right now, I want to be mindful of your time. This is a quick overview of what we're going to be covering. So if this isn't something you're interested in, feel free to go join one of the other great talks here, or you won't hurt my feelings. Just leave a couple dollars in the jar in the corner for my therapy, for my abandonment issues, and just come back at the end for a link to the slides. So basically what we're going to cover today, I'm going to talk about some of the typical GPT tools we have right now, like Copilot, Code Whisperer. We're going to take a quick look at some high and low level prompts and see what it can do well and what it can't do. And then we're going to go through some issues of AI code generation, because if you sit down and take a critical look at it, it's still got a long ways to go. After that, I'll give you some tips for how to help junior developers come along, protect their career. And then I'll get some tips for senior developers, things you can do so you don't get cashiered right at the end of your career. Then we're going to talk about architecture and a tool called ArcUnit, which I think would be useful in combating the tsunami of code that's coming from us from all these AI tools. So that's basically what we're going to cover today. And again, if this isn't something you're interested in, come back later. I've got another talk after lunch. Okay, let's get started. This is me. I'm Kelly Morrison. I've been in the computer field since the 1980s. So I'm getting pretty old. And as you can see, I've worked for quite a few companies. I have a bachelor's degree in mathematics from the University of Georgia, and have a doctorate in computer engineering from Auburn University, which isn't as impressive as it sounds since I got it about 25 years ago, which was a long time ago. Things have changed completely, but I have kept up with things. And it's been an interesting career. You can see a couple of Atlanta companies on there, like Home Depot, CNN. Actually, I work with that guy right there, Adam Stark. Great guy. Currently, I'm working on Edward Jones, and I'm actually working on a mainframe right now, JCL. So I'm here talking about AI and then going back to my day job like COBOL and JCL, which is an anomaly. Usually it's more interesting, up-to-date things. But this is just a quick overview of who I am. I work at Doherty Business Solutions. It's a consulting firm based in St. Louis, but we have a pretty large Atlanta office. And if you're interested in coming to work with me, just come by and talk to me after the talk. Okay, I was trying to think of a picture to basically give you my feeling about AI. This is what I feel like. And I actually went and did this with Photoshop because I couldn't get Midjourney or Mistral or anything else to generate a good one for me. So this is what I feel like. I kind of feel like Rocky in the ring with one of the Rock'em Sock'em robots. I'm still here plugging away. I'm really good at what I do because I've been doing it for a long time. But I'm up against a foe that's mechanical, doesn't feel pain, won't stop, can't stop, and will beat me to a pulp if I let it. So this basically sums up the way I feel about AI. And this is the days where I go home and think, oh my God, I should have been a farmer. People are always going to eat. But, if you just calm down a little bit and go back and think about it, we still have a lot of opportunities, and it actually could be a lot more fun for us in the near future. Something else I think about occasionally, this is a frame from an old comic book called Watchmen. You've probably seen the movie. There was a frame in it. Basically what was happening was there was a superhero named Dr. Manhattan. He just burst on the scene, changed everything. A lot of things that changed political situations. And one of these other superheroes decided, that's it, I'm retiring. I'm going to go back. I'm just going to work on cars. Even you can't do anything about that. And he turns around and says, well, now that we can mass produce lithium, we'll have new electric cars, and they'll be really easy to work on, almost no moving parts. And the guy's sitting there thinking, great, there's my other career gone. And I thought about that a lot back in 1986 when I read it, and it's really weird that 38 years later, this is actually happening right now. So I think about that a lot. Okay, let's take a quick survey before we get started here. I got two questions for you. First of all, who's afraid they're going to lose their job to AI? Okay, not as many as I expected. That's good. Second question, who's already lost a job to AI or knows somebody that has?
Probably that, not you.
Okay. I wouldn't mind losing my job running COBOL right now and getting a better one, but I'm happily employed. So. Okay, if you are worried that you're going to lose your job to AI, I'm here to reassure you. I won't give you a body hug like that, but hopefully we'll make you feel better before you go out and eat lunch today. So let's take a quick look at what popped up in the past couple of years, because it seems like things changed almost overnight. There was that seminal paper in 2017 about transformers, and then about a year later, the LLM started coming. GPT came out first from OpenAI, started basically an LLM arms race. Now everybody's like trying to beat themselves up to be the winner in this race. So this is still fairly recent. I mean, 2018, that was only 6 years ago. And if you want to like measure how these things have been increasing, one of the first ones, GPT-2, only had about 2 billion parameters. A little bit later, GPT-3 had 175 billion parameters. That's 80 times as many. And then GCP-4 has 1 trillion. That's 1 trillion ways that you can influence the results coming out. So it's a pretty remarkable increase. And hopefully that's helping NVIDIA, because I own a lot of stock in that company. I'm very happy about that. There was also GitHub Copilot. This was a sneaky move from Microsoft. Microsoft's made some great acquisitions. They bought GitHub years ago, and they also have a collaboration going with OpenAI. And they started realizing ChatGPT is great at just like sucking in the internet and breaking it up and like giving you answers based on that. But we own a lot of code. Well, not own it, but we have access to it. Because there's billions of lines in GitHub. So they kind of quietly ran their training tool on that code. So they came out with a specialized version of it. It's called Codex. They may have changed it since then. But Codex was a special model based off of ChatGPT-3. And it was specialized for working on code, being a code developer. They trained on billions of lines of code from GitHub, and it can also learn from a local code base. If you install it locally, it can look at the code you've already written in your project, and it can give you recommendations based on that. So it's interesting when it's different from the general ChatGPT-3. This one is basically looking at code and trying to be a master of that. Then there's Amazon Code Whisperer, because Amazon wasn't going to be left out of this race. So they started thinking, like, we've got AWS, we've got a lot of code sitting out there too. Let's run our little ChatGPT look-alike on it. So they came up with Code Whisperer, and they trained it to generate code for 15 different languages at the time I made this slide. And that may have actually increased by now, or maybe more. This one, surprise, surprise, is specialized for AWS cloud deployment. Amazon wants to promote that, so they've got a tool to make you a great AWS developer. And it looks at codes, and it looks at comments that you write, kind of like Copilot does, and they'll offer you help based on it. How many people here have used Code Whisperer? Okay, not as many as I thought, actually. Interesting. So we got these tools. There's an arms race going on. They get more and more powerful, but how good are they really? So what I decided to do was try a couple of examples. I came up with a low-level example, the kind of task you might give a junior developer, and then I came up with a high-level one, the kind you might task a system architect to do. And here's what I gave the junior programmer to do. What I asked it to do is to write a Java 17 Spring Boot REST API, and I wanted to take baseball statistics and put them into and out of a MongoDB database. I told it I want JUnit 5 test cases, because I want something up to date. And I told it to check for the 5 most common REST errors. Remember that part, because you'll see it didn't. Okay, so I gave it that prompt. If you give it to a junior programmer, it could probably come back in an hour or two and have something knocked out. This one came back in just a couple of seconds. And at first glance, you're like, oh my Lord, it actually wrote the program for me. I might as well become a farmer now. But if you actually look at it, it's not as impressive as it looks. For example, over here, you've got the MongoDB config file. And you can see right off the bat that it does a few things that I wouldn't like. It's hard coding information in it, which you would expect for an example, but if you gave a junior developer this prompt and told them to copy and paste this into it, that's not something you really want in your code base. And it's not exactly obvious if you're like a beginner Spring programmer how you get information out of a config file and into a config class like that. So this right off the bat is something that you'd probably want to change a little bit before just blindly copying and pasting. Second, it actually came up with a little baseball stat record. This describes the data it's going to put in and out of the database. And again, there are a couple of issues from it. Remember I asked it for Java 17 code? what I was hoping was that it would take advantage of the new records that came in with Java 16 or in 17. But it didn't. It just came out like a regular public class. And it actually used the Lombok data annotation. Now, Lombok is another issue here. I used to use Lombok a lot. It was great. It's basically a lot of annotations you can add to your Java code. It takes care of a lot of the boilerplate for you. But it's kind of fallen out of favor recently because Java's advanced. A lot of things that Lombok used to do for you are now baked into Java. So a lot of programmers are actually starting not to like Lombok. But I thought it was interesting that it went back to the old favorite Lombok instead of using the new Java 17 records. Now, there may be a reason for that. Maybe it doesn't work with the Spring framework. But either way, it just gave me some code and said, here it is, don't worry about it. So again, that's like something else that you might want to think about. If you were trying to work this in your program, you may want to tell it, like, give me the program, but don't use Lombok. In fact, you might want to say, don't use these frameworks, do use these. Okay, it also knocked out a REST controller. Nothing really interesting there. That's basically the same one I would have done. The only thing I would have done differently as an architect there, you just see it's just /API/baseball. I would probably have versioned that, so you can have multiple versions of the API out at once for people that are migrating. So again, that's something that I think it could have done better. And then over here, it actually knocked out some REST endpoints. And you can see it got really lazy about it. It just said, here's what the signature looks like, you do the rest. And the sad thing is, this probably won't even compile, because none of these return anything, even though it's expecting a response entity to come back. And you think if it's going to try to be the great programmer for us, it would actually give you something that would compile. Would it have hurt it to at least fill in one of those for us? No. So lots of issues here. Right. And then I asked it to do some Spring unit tests, and it did that. And actually, I'm pretty happy about this. This is one of the better things it did. If you've ever worked with Spring, writing Spring is a decent job. Writing Spring tests is like an order of magnitude harder. It's harder to write the Spring test and get those right than to actually write the Spring itself. So it actually came out with a pretty good framework here. It showed you how to use Spring Boot tests, auto-wired instance services. It did make a few interesting architecture decisions, though. You can see it brought in Mockito, which is not bad. Mockito is one of the most popular frameworks out there for unit tests. But you may want to use something different, like Spock or something like that. Also, if you look down here, let's see. The baseball stat line where it's creating a John Doe 2050, that isn't very clear code to me. For example, I hate mystery parameters. What does 20 mean? What does 50 mean? I don't know. If it was going to bring in Lombok, you would think it would have slapped a builder onto that. So you could have a fluid interface. So baseball stat, .name, John Doe, .home runs, 20, etc. So again, that's something else that could have done a little differently. And finally, it's not really a great idea to auto-wire fields. The standard convention is to have a constructor and auto-wire the dependent things into that. So overall, it's not bad. It generated pretty good code. It's something that would probably work if it had filled in the REST endpoints for you. And if you're a junior developer, you're thinking, this is great. I can just spit out a few lines. It'll do the code for me. I check it in, and then I can sleep for an hour until the stand-up. Now, on the other hand, if you're a more experienced developer, it's a little different. And I'll give you a second to read this. This is the kind of thing that I would expect a senior developer to do, or an architect. Okay, so this is basically saying I want to set up my enterprise software. I've got all these great things I want to do. I want OpenID security, I want unit tests, integration tests. I want to set up a deployment pipeline. I want to support a lot of concurrent users. I want localization for several different countries. I should handle PII. Sarbanes-Oxley. I don't want to be the next Enron. And it should provide documentation so we can figure out what the heck you did. So I typed this prompt in, and what do you think it did? I thought about it for a minute or two, and I was sitting there. And then I finally came back, and guess what? It punted. It didn't do anything I asked. It just gave me this happy, feel-good document saying, you need to define some requirements here. And I saw that, and I was thinking, yeah, my job's safe for a while to come. Okay, so the upshot of this is we still need architects. I mean, yes, it's getting really good, and it's going to be able to do what junior programmers can do. But we're still going to need architects for the foreseeable future. That prompt I showed you earlier, it's going to be a long time before any of these systems can handle something like that. Can you imagine it spitting out like hundreds of thousands of files with millions of lines of code, and then you just blindly say, okay, I guess it works. No reviews, no humans touching it. Just like, here's like they said in the keynote the other day, here's a tsunami of code coming at us. We don't know what it does. So we still need architects to guide these things. So AI can do the ground level work, and actually this is great for people like me because instead of having to delegate stuff to people, I can just do it myself. I can knock out like the basic services, stuff I used to have to like hand off to a junior programmer and then, do PR reviews and offer feedback and make sure everything tested properly. But now I can pretty much do it for me. I can make a few tweaks and I can actually concentrate on some of the higher end stuff. Okay, there's some other issues though. AI-generated code still got a lot of problems. Let's go through and look at a few. One, garbage in, garbage out. This has been a truism in code for years and decades, and probably will be long after I'm dust and basically fertilizer in a flower bed somewhere. So what we have, GPT-3, Copilot, Code Whisperer, those were all trained on repositories of code. And that code came from everybody. It came from people that are geniuses. People that write code so sweet, you just want to give it a chef's kiss. And then you have like high school students that don't even know like what a program is, and they just type some stuff in, it doesn't compile, but they just shoved it up there to get some kind of grade, and it's in there. And these tools can't tell the difference. They don't know what the good code is, they don't know what the bad code is. So they were trained on a lot of code, not all of it's good, not all of it's correct. Some of it doesn't even make sense, and some of it's obsolete. For example, if there's Java code out there with vectors in it, you don't want it recommending that. That's been dead and buried for years. Then the late George Carlin, he used to have a great quote, I always think about it, as far as like programmers. Think of how stupid the average programmer is, and then realize half of them are, stupider than that. Present company excluded, of course. You people are great. You wouldn't be here if you weren't interested in furthering your careers. But if you think about it like that, these are the people that train these models. These are the people that put the code in there that, Copilot is emulating. So you got to think about that. Then my favorite, hallucinations. GPT, as much as we call it intelligence, it doesn't think. It doesn't know what it's looking at. To it, it's just like random things that cobbled together. Basically, the way these LLMs work, they go out and just suck in a lot of data from the internet, and then they break it down to tokens. And then they basically measure how close the tokens are. For example, if you use this word, the ones most commonly used around it are these. For example, if I say happy birthday, like close ones are to and you. So it basically just broke down all this information and then goes back and tries to figure out what's most probable for something you ask. So it's not really thinking. In fact, it's not thinking at all. It's just a mime. It's a mimic. I call it a parrot. It basically just you tell it what you're looking for, and it puts together something that it thinks, that it can put together that looks like what you're asking for. Now, usually there's prior information out there. There's a ton of REST services checked into GitHub. So if you ask it how to do a REST service, it's got a lot of examples. Most of them probably work or they wouldn't be in GitHub. So you got a good shot at it actually coming up with something that looks good. But on the other hand, there's stuff in there. You could ask it some weird stuff. For example, how would I write the operating system for a nuclear warhead in Pascal? And it's not going to find anything like that, and it's just going to hallucinate something. It's going to find the keywords, find what's close to it, and cobble together some weird answer for you. So the hard part is you never know when it's making stuff up and when it's not. Sometimes it can put together some pretty convincing lies, and that's one of my hardest issues with it. So that's something we've got to worry about. Here's an example of hallucination. I was working on a project a year ago, and it was working with Kubernetes. I hadn't used it in a while, and I was trying to remember how you rename a pie. So I decided, well, I'll ask ChatGPT. And it happily came back and said, oh yeah, just use the -- name option. That'll rename the pod for you. So I tried it, and guess what? Keep Control's like, yeah, I don't know what that is. I've never heard of that option. So I searched online, couldn't find it anywhere. So I told it, hey, it doesn't recognize that option. And ChatGPT is like, oh, you caught me. Sorry. Yeah, that one doesn't exist. Yeah, just ignore that. So if you've got tools like this, giving advice to junior programmers that don't know this in the first place, it's going to be really frustrating for them. So it'll generate some code correctly for them, but others it's going to just frustrate them, give them a really rough day. And again, there's monkey see, monkey do. Again, it's trained on stuff that's out there in GitHub, stuff that's out there in AWS. The problem is, what happens when you have new technology, something brand new? For example, Rust came out in 2006. It's a brand new language. How many programs do you think were in GitHub for it by 2007? Not very many. And a lot of them were probably people fumbling around trying to learn how to use it. So if you were training it on that and asking it for examples of Rust, you probably wouldn't have gotten very good answers back then. Another example, Mojo. How many of you have heard of that programming language? Wow, that's probably why my talk at DevUp got rejected on it. Mojo is a brand new programming language, just came out about a year ago. It tended to be a superset of Python, but with some new constructs built into it for working with AI. For example, it has tensors, that kind of thing. And can do parallel execution of these things. But it's a brand new language. There aren't that many programs for it, but it looks like Python. So if you were to ask, for example, Mojo programs, it would probably come up with Python. And some of those probably wouldn't work because even though it's intended to be a superset of Python one day, they haven't implemented it all yet. It's only a subset of Python. So right now it's a subset of Python plus some brand new stuff that's not in Python. But the stuff that's been trained out there is very little Mojo, a lot of Python. Yes? Oh, okay. Sorry. Yep. So the problem is, when stuff is brand new, it's a new paradigm shift, it's not going to have a lot of data to train on. So it's probably going to be more likely to hallucinate or just give you just completely weird stuff. So that's something we have to worry about. Then there's security concerns. This is a big one. This is what keeps it from happening at a lot of companies I work for. ChatGPT, anytime it interacts with you, it trains from you. That's one of the things it does. You give it information, it kind of sucks it in, spits it out there, and then it's out there. And the problem with an LLM is once information gets in it, you can't just delete it like you can with a database. For example, if I accidentally put my social security number in, say, an Elasticsearch database, it's pretty simple to search for it and delete it. Boom, anybody that's had a day or two of database training can do that. Do you know how hard it is to get information out of an LLM? It's almost impossible. In fact, that's actually a really hot research topic. If any of you can crack it, you could probably make a few million. But the reason of that is, remember the way an LLM works. It basically tokenizes things, spits it out there, it builds it up into all these relationships, and it's hard to know where it is. It's just spread across the winds. So it can come back out, but it's almost impossible to get it out there. So you got to be careful about getting things like passwords out there. You've got to be careful about intellectual property. For example, if you've got a new MPEG encoding algorithm that's 10 times faster than anything else, you don't want that out there. You want to keep trade secrets, your secrets. And because of these reasons, a lot of corporations won't let you use these. You cannot use the Copilot. You can't use ChatGPT 3. Or you can use it, but you have to air gap it, and you have to make it anonymous. For example, you don't want to ask ChatGPT, how would I write an OS for the XR-37 nuclear warhead? But you could ask it, how would I write a REST service for baseball API? And then take that and modify the code so it looks like what I want. So that way you take something innocuous, but you translate it to something that's what you really want. So that's one way to get around some of the security concerns. Then there's debugging. We've seen that it can generate code and it can make up stuff. So how do we know it's right? Well, we can ask it to write unit tests, but those might be wrong too. It might be covering up its sins. So And another problem is, what happens if you deploy some of this code, nobody understood it, nobody actually looked at it, and then something breaks in production? Can a human actually go in and understand it enough to fix things in a timely manner? You know, sometimes you can like paste the code in the tools like ChatGPT and Copilot, and it can debug it. But again, that could give out like some of your private information, so it's things you might not want to do. So we got to be careful about making sure that the code it generates is actually something that's good. You know, that's an opportunity for us. We'll see. Then there's some things that are just easier for humans to do. You know, and these are usually like the big, widespread tasks. Sorry about that. It's pollen season in Atlanta. My throat's yellow right now. So some of the things that are easier for a human to do right now, for example, let's say you want to change frameworks. Like let's say you got a big legacy application that uses Lombok for logging, and you want to use SLF4J. You could like dump your entire code base in and have it spit it back out and then have like the mother of all PR requests. Or you could just like, you know, assign some junior programmers to do it. It's like, you know, fairly easy to do. It's just tedious. You know, so that's something you could do. Other ones, like when Angular switched to Angular 2, that was basically just a rewrite. So everybody had to go back and rewrite their code. You know, and again, you don't want to dump the whole application in, have it rewrite everything, and then check everything back in again. Project managers like have nightmares about you checking in the entire code base every week. So other things like when Java changed dates to the Java 8 datetime API, that was a pretty major switch. And then some things you just need human eyes on. For example, if you're tweaking CSS, you know, computers are great, but they don't have the best style. You know, you want human eyes, like, you know, somebody's a UX expert to look at a interface and say, yes, that's pretty, or oh my Lord, we're going to lose customers if we push that out there. And this happened before. One of the first jobs I had, we had a company bought us out, and they had us put together this red and black interface that looked like something straight out of the fires of hell. The program was called raster serve because it would rasterize images and spit them out to printers. We started calling it Satan serve, you know, and that thing lasted about 3 days on the market before customers were screaming at us to fix it. You know, but that's the kind of thing that a computer might do. Computers don't care about color. They don't know about aesthetics. You know, they're just going to like say, hey, we're going to use blue here and red there. You know, done, ship it. So that's something you need human eyes for. Then there are architectural changes. For example, let's say you got a big ball and mud design, and one day you decide, we're tired of dealing with this, we're going to redo it using DDD, you know, domain-driven design. You know, that's a pretty major rewrite. You know, and you could either have the Copilot or ChatGPT just regenerate the whole thing from scratch, which I don't want to have to approve, or you could just like, you know, let the junior programmers take care of it, you know, with some of the seniors guiding it. And then, like, you know, you got to understand when requirements change and the impact on the code. Like, sometimes there are things that, like, a computer just doesn't understand. Like, a couple of years ago, we were using AWS for storage. And then all of a sudden, once we got to using it pretty heavily, they raised the rates by, I think, a factor of 8. You know, and our CEO came spitting mad into the office. He's like, we're getting it off there today, now. You know, we're moving it into our own server farm. So that's the kind of requirement that, you know, when your CEO tells you, you understand it. It's like, okay, this is a priority. Computer's like, oh, you want to move it? You know, it's fine there. So then there's industry reluctance. We've already seen pushback against AI in a couple of places. For example, law. There's been a couple of cases. There's one that was mentioned in an earlier talk today, where a lawyer actually, like, you know, basically built up a case history using ChatGPT. ChatGPT just made up cases. Not a single one in the history was a real case. And the judge started checking it out because he's like, I've never heard of this one, never heard of that one. Turned out they were all fake. You know, and now that lawyer's actually facing sanctions, may get disbarred. There was another lawyer, actually it was a person that wanted to be a lawyer. He actually trained a ChatGPT model on law books. And when he got a traffic ticket, he wanted it to go into the courtroom with him as his lawyer. So instead of taking a lawyer in with him, he wanted to carry a laptop in. Lawyers do not like that. You know, if you're billing $300, $400, $500 an hour, and you can suddenly be replaced by somebody with a $10 monthly subscription to like mylawyer.com, like, they're not going to like that. So there's going to be a lot of resistance there. Hollywood had a strike recently. They had a problem with that. One of the big issues with that was ChatGPT coming up with episodes of TV shows, movies, that kind of thing. You know, and they had some pretty severe problems with that. Software development could be next. I've been wondering about that. I've seen talk about forming unions for software development. It's something we need to keep an eye on. And then there's the issue of, can you actually even copyright the software it generates? There was a case back in March of last year. Copyright Office, they kind of waffled on it. They said, they may be copyrightable, but not for now. So companies don't like it if you, have a lot of code created for them and they don't own it. That's the issue for them. So that's kind of a fuzzy area. There's critical software. There's some software I think computers just shouldn't be allowed in the air, at least not until they're much, much, much better. For example, avionics software. If you knew the avionics software on your Boeing plane, well, that's the bad one. If you knew the avionics software on your Airbus plane, was generated by ChatGPT, would you fly on it? I wouldn't. I want people working avionics software. Full self-driving car software. Tesla's getting pretty good about that. But still, I'm afraid, I'll be going down a hill and it's going to see a weird reflection on a hill. I think it's the Wile E. Coyote tunnel and just slam me into a solid brick wall. We don't know how this stuff works. It's just cobbled together, nobody understands how it works. It could happen. Then there's embedded software. Do you want a pacemaker running something that ChatGPT generated? I don't think so. And then some stuff's just horribly expensive. If you got one shot at getting a $3 billion rocket to the moon, you don't want some weird hallucinated piece of code to crash it to the Pacific Ocean. So there's always going to be some software that I think is going to be relegated just for humans. And then there's lack of contextual awareness. Computers are great at what you type into them and what's processed, but it doesn't know about other things happening in a company. For example, it might not know about company standards or practices. For example, there are certain companies I've worked for that have their own UX toolkits. So you don't use toolkits from elsewhere. You don't use the really nice Vaden software. Vaden, I'm never sure how to pronounce that. Anyway, they've got a nice UX toolkit. They're advertising outside, but some companies have their own and they want to keep it for consistency's sake. Then there's some times where you just have personal beefs. For example, there's one major company in Atlanta I won't name. They will not use AWS software because they view Amazon as a competitor. So everything they do is GCP. And again, that's something a computer wouldn't really understand. And then sometimes, like my former CEO, he just got mad at the rates going up. So he didn't like it. So there's a lot of things that affect the software development that computers just don't know about. And we're almost through these. I'm trying to build up a case for how these things are not really that great. This is a big one for me: lack of creativity. Remember, all they do is go out and take all this stuff on the internet, throw in a wood chipper, and then kind of reassemble what came out of it. But they can't really come up with anything fresh and original on their own. For example, sometimes I wonder, could an LLM have ever created DVR time shifting software? Could it have created TiVo? Probably not. The MPEG-4 encoding algorithm, that thing's a piece of beauty, if you've ever looked at it. I don't think a computer could have come up with that, at least none that we have now. The whole theory of grammar and compiler theory, LR and LL grammars, I don't think that a computer could have come up with that. Although Amazon did have that one where they had two servers that kind of developed their own language for talking to each other. That was kind of weird, but it's nothing that people would understand this. What about the layered internet protocol? I don't think computers could have come up with that based on what they've already seen. Self-driving a car in areas with different laws, you might be able to do 80 on the interstate in Atlanta, but if you do 31 in a 30-mile-per-hour zone in my hometown, you're getting a ticket. And then LLMs and transformers. Do you think an LLM could have figured that out? Probably not. So I think there's always going to be room for pure original thinking. So if you really have some gray matter up here, and digging into things, doing research, I think you'll always have a job. How are we doing on time? Okay, so I've given you the worst case scenario about things it can't do very well. What can it do well? Well, we've seen it can do low-level code generation pretty well. You may have to guide it a little bit, tell it don't use these frameworks, do use these. I want you to make sure config data is done properly, make sure you handle SQL injection, stuff like that. You may have to give it some really detailed prompts, but once you do that, it can probably come up with pretty good code. It can do a good job of code optimization. One of the things I like to do is like dumping some code into it and say, hey, make this faster. Next thing, it can make some good stuff sometimes. It's pretty good at greenfield development. It can like set up a nice structure for you. It's great at documentation generation. Like one thing I like to do is dump a regular expression into it and say, please explain this to me in English. So, you can take these gnarly things that look like a chicken walked across your keyboard and it'll explain it in plain English. And it can actually write test cases. You can dump in some code and say, hey, write a test case suite for it. So it can basically do like, junior development tasks right now. So if you're a software developer, what are you going to do? Let's look at two different cases, the junior developers and the seniors. And I'll start with the juniors first. If you're a junior, I would focus on architecture, not coding. You might be the most brilliant Rust programmer in the world, but chances are ChatGPT can do a pretty good job in just seconds. But what it can't understand so far is architecture. It doesn't understand all the different kinds of architectures or what might be the best for your particular case. Don't just learn a language or framework. It's great to be really good at Python. It's great to be really good at Rust. But what you really want to do is learn which languages are best in which situations, the trade-offs, the common idioms. For example, if you're going to write system software, it's probably going to be C, C++, or Rust. Probably Rust these days. If you want to work with AI, it's probably going to be Python, because Python's got like great access to most of the libraries used in it. If you're going to write like a front end for a web service, probably TypeScript. A lot of y'all use JavaScript. Please use TypeScript. So learn which languages are best so that you can guide the prompts. Another thing, like look beyond what's in the computer. For example, like some things might be too expensive. Oracle's a great database, but I don't want to be sending a Cadillac a month to the people there. When you could use something cheaper. Sometimes libraries might not be available. Sometimes there's just not a library you need, or sometimes using a third-party library that enforces dependencies on you. And sometimes you just can't find programmers you need. For example, I worked on one contract. It was a company that had a lot of Scala programmers, Scala. Some say Scala, some say Scala. But anyway, most of the people there were Scala and Clojure programmers. The problem was it was this fairly small town, and they were having a hard time finding people that understood Scala or Clojure. So while I was there, they decided to move everything to Java, and people just about had a complete walkout revolt. But that's one of the things that a computer doesn't see. It's a human factors thing. It's an environment thing. It doesn't see it unless you tell it about it. Then learn the architectures that are best implemented in various languages. Some languages are better than others for different kinds of architectures. You need to learn how to do great prompts. When we were walking through the code generator earlier, for example, you want to tell it to get config information from somewhere external. You want to tell it not to use older libraries. You want to tell it to use newer language features. So there's a lot of stuff you have to do for prompts. And then finally, and probably most importantly, if AI is going to be writing a lot of your code, you need to at least be able to understand it. So if something goes wrong, you can go fix it. Because if it's 3 a.m. and somebody calls you up and says, hey, we need to get this thing up and running in the next 30 minutes, AI is probably not going to do it. Okay, if you want to be a senior developer or an architect, I would recommend studying architecture. These are a couple of great books. Did everybody see Neil Ford's keynote yesterday? Okay, these are a couple of books he wrote, the bookend ones here. The older one is Building Evolutionary Architectures. If you were in the keynote this morning, Jackie, she talked about architectural decision records. Building Evolutionary Architectures talks about that. Fundamentals of Software Architecture is great. In fact, Neil gave a keynote about it a couple of years ago here. This book, he actually goes through a lot of common architectures, explains them. He tells you the trade-offs, why they're good, why they're bad, when you would use them, in what situations. So that's a great one to look at. And then the middle one, Domain-Driven Design, that's an older book, but it's really good about teaching you how to go in and understand requirements for a project, how to talk to people, and how to take what they know and turn it into something that can be programmed. So it's basically becoming a front end for the prompt generator. And then there's a brand new book that Neil wrote. It's called Head First Software Architecture. This actually just came out about a month ago, within the last month. I haven't even had a chance to read it yet. But Raju Gandhi, one of the other authors on this book, he actually works at Edward Jones, which is my current client. So I got to talk to him a few weeks ago. He was really excited about this. The book had just gone to press. he was looking forward to it. But the Head First series is great. They have a nice structured approach. They use NLP techniques, so the stuff kind of seeps into your brain faster. I would highly recommend that. So while you're studying architecture, there's a lot of them. You probably don't realize just how many there are. Here's a couple I thought of just off the top of my head. There are layered architectures. There's also a related one called hub and spoke. There's event-driven architectures, microkernels, microservices. Then there's some called space-based architectures, which use something called tuple space. There's client-server, broker, peer-to-peer, orchestrated. There are all these different kinds of architectures, and there are places where they're good, places where they're bad. Your job as an architect is to figure out what these are, figure out which one's best for your situation, so then you can tell the prompt generator how to generate code for that architecture. Defining requirements. Somebody's got to type the prompts in, and the domain experts probably aren't going to tell it. I was working at a client a while back. They basically did crop science, and I was working with one of their experts. This guy was a genius. If you could grow plants on the airless, waterless moon, he could do it. He knew that much about it, but he didn't know anything about programming. So what we were trying to do, I had to sit down with him for a number of interviews. And we carefully, talked to him, tried to understand what he did, and we basically figured out enough to map it into a program that he could use for his work. So that's one of the things in architecture an architect can be. You can be the bridge between domain experts and the AI code generator. So what you need to learn how to do is how to guide them. That domain-driven design book actually has a couple of conversations that show how to go about that. So that's a good one. And you need to learn how to take all these architectures you've learned about, figure out which one meets your particular situation, and then describe it to the prompt. For mentoring junior developers, there's some things you can do to help them so they don't get replaced immediately. Work with them, teach them how to write high-quality programs and high-quality prompts. So, you don't want to just say, write code for a REST API. You want write code for a REST API that handles security, blah, 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 uses JWTs for security, that kind of thing. So teach them how to write prompts for that. You also want to tell them how to spot hallucinations. They need to know when code's bad. And the only thing you can do with that is just work with them. Spend time on PR reviews. Don't just say you need to fix that and then that line's got to go. Actually talk to them about what they did and the style and how they went about it. Try to train them. You don't want to just take people into the conference room on Friday at 1 o'clock and say, we're going to talk about architecture for an hour. Because people will tune that out. But you can do it in small bite-sized pieces throughout the day, throughout the week. And eventually this stuff will settle in. For example, one thing you can do is don't just say we're going to implement X using framework Y. Add on to it. So we're going to implement X using Y instead of these other frameworks because, and then tell them why. So you want to let them know you're thinking when you're making these architectural decisions. So this will help them come up to speed more quickly. So, and then another thing that we're almost at the end here, so don't worry, you'll get to lunch. Another thing is architects can do, like Neil said, and I can't get this phrase on my head. We've got a tsunami of AI generated code coming at us. One of the things we can do is to fight fire with fire. If AI is going to generate code, then we can write code to double check on the AI. Make sure it's enforcing the decisions we make. And there are tools you can do for that. There's one called ArcUnit, and Neil actually mentioned that the other day in his keynote. I was watching it, and he started talking about ArcUnit, and I'm thinking, Neil, you're taking my presentation away. In fact, he used some of the same examples I had, but it's a great one. If you're not familiar with ArcUnit, how many people here have actually used it? Oh, wow, actually more than I thought. ArcUnit is kind of like JUnit. JUnit helps check that the code you wrote is correct. ArcUnit lets you write test cases to check that your architecture is the right one when you specified and that it meets all the requirements of it. And it's got a nice fluid interface. It's really easy to write in an IDE. You can write your own architectural rules. Here's a quick example of it. These are a couple test cases. You can see that instead of at test, it's at arch test. And there are a lot of built-in ones. These long, underscore strings here, no classes should throw generic exceptions. These are ones that are already defined. All you have to do is include them in your rules. So for example, like instead of just throwing like new exception, you could like force people to like, use a more specific exception or a custom one. Java has built-in logging. Nobody uses it. We can make sure that the AI doesn't sneak it in by using that rule. If you use loggers, a lot of people want them to be private static final. So what you can do in this one, this is like a handwritten rule. It basically says, like, look at all the fields and classes that we have. And if any of them, those fields are logger.class or some kind of subclass of it, then it should be a private field, and it should be a static field, and it should be a final field. And you can actually put a reason for it, because like we agreed on this convention, or because John said so. So you can actually add like justifications for your rules. This one says that you shouldn't be using Jota time. Ever since Java 8, we've got a nice time API. So if you still have code out there that uses that, or if AI tries to sneak some in, you can tell it, no, we're not doing that. And then no field injection. So this gives you an idea of the kind of things you can write.
So these are the predefined exceptions?
Most of these are. All the ones that look like constants here, those are predefined. And there are quite a few more. This one shows you how to write your own rule. You basically say, I have an arc rule, and it has a nice fluid interface. Usually it has like 2 or 3 things. The first one tells what you're operating on. For example, you can look at packages, classes, you can look at fields and classes. So for example, this one says, look at all the fields in this application. So I'll go through all the classes in that program, and I'll look at all the fields in them, and then I'll run this rule on those. And it checks for anything that's a logger or subclass of a logger, and make sure it has the right visibility. There's Java, C#. I think there's some other ones now. There's something similar for Python now. I haven't used it myself, but there is one available. But this is the kind of thing I think we're going to be doing more and more. We're architects. We've got a lot of bad code and good code coming our way. We need to make sure it meets our architecture. So I think we're going to be spending more and more time like doing things like this, to like check what the AI is generating for us. Here's a more detailed exception. We mentioned some of the architectures earlier, and there's one called a layered approach. This is basically your basic presentation layer. Usually you have 3 layers. There's a controller layer, then there's a layer of services, and there's persistence layer where you store stuff in the database. So what this one says is that we have a layered architecture, and we want to look at everything in it. And we have 3 packages here. This controller package is the controller layer. The service package is the services layer, and this persistence package is the persistence layer. So once you've told it where each of the packages for these are, then you can start writing rules against it. For example, anything in the controller layer, the other 2 shouldn't be able to touch it. You shouldn't be able to call from like a database class to a REST controller. The services layer, it should only be addressed from controllers. For example, controllers can call a service to do something. Services shouldn't be able to call a REST controller. And again, controllers shouldn't be calling the database persistence directly. It should be working through a service. And then the persistence layer, only the services layer should be talking to that. So if you have AI that tries to sneak in code where, say, the database tries to talk to a service or a controller, this kind of rule will catch it. And you can do this for all the other kind of architectures. You can build up your own. So when it checks in code, you can run rules about it, make sure that it's conforming to your architecture. Okay, and we're finally at the end. So in conclusion, AI can do a lot of junior developer tasks. We've seen that already. It's still a long way from being able to replace general programmers, though, especially for software architects. I don't see that happening before I'm retired. Some of you, not sure, but you should be good for at least 10 or 20 years. And in fact, I think it's going to make it more fun, because you can concentrate on the higher level aspects instead of down the dirty grunt work. One thing you're going to need to know is how to work at a higher level. Learn different architectures, learn why they're useful, learn when they're good, when they're bad, what the trade-offs are. We need to be teaching up junior developers to help them with AI. We need to help them learn how to specify great prompts, how to check the code that comes back, make sure it makes sense, make sure it's documented, make sure no security holes. And finally, like I said, we can get better quality tasks. If we can get the AI to produce like solid code, and then we work on like tying it together, we should be able to work pretty quickly. So that's it. I'm done with this presentation. Here's some links for you. There's a QR code up here where the slides will be on GitHub. They're not there yet. What I usually do is like present a presentation, then I go home, and if there was anything that wasn't clear or if people had comments, I'll make a few tweaks and then I'll upload it. So that's where the slides will be this weekend. They're not there yet. If you want to add me on LinkedIn, that's my QR code at the bottom. And if you want to talk to me, there's my work address and my personal address. And thank you for sitting through this talk. Here's a picture of my cute puppy dog, Daisy May. She's sitting at home wondering where I am. Thank you, appreciate it.